So, quick bit of background. I've been trying to get some more complicated multi-node, multiple Ethernet interface tests going in Lava for LNG. And that has meant I've been working quite closely with Dave and Neil over the last year or so, helping to work out how to do those, and also finding some of the limits, which may not necessarily be in Lava, but might be in the documentation or in my understanding of it or whatever. It was quite a learning curve. I can't even see this. So, Lava is, as far as I can tell, it's powerful, it's flexible, it's useful, but it's also daunting, difficult to understand, and maybe sometimes not all that useful. How does that match up with other people's experiences? It has. I'm seeing some smiling and some nodding. How are people using Lava? I should make it clear, this is not a presentation. I very much want to hear stuff from other people. We've got about 4 or 5 slides here just as an introduction, so please, hands up and shout. Please share with us what you think is good or not, what's helpful, what's not helpful. How do you do things? Are there any things that you do that you found are really good ways of working with Lava that actually the documentation doesn't mention, or you think you found a really good, undocumented secret way of doing things? We'll come to the end. Shush you. And also, what would you like in future? Oh, I should make a point here. Neil is here taking notes in Etherpad. He's been told explicitly he's not allowed to talk. So, equally, if people are not using Lava, and I know there are some people who aren't, why not? Please be honest with us. What are the problems you've had? What's missing? What does Lava not do for you? And how can we help? We're going to have a very brief discussion about the future, but we'll leave that. It might happen. And then please talk to us. We're taking notes. Don't worry. We're not going to send hitmen out to pick off the people who are brave enough to complain. We really want to find out what people find good or bad, so that we can make more of it good and less of it bad. We'll follow up with these on hopefully regular sessions at Future Connects. There is a lot more work planned, and there was going to be more resources needed. We'll come to that in a bit. So, who wants to go first?
Okay, so recently started working with the art team from ARM. They are optimizing AOSP, not to mention the A word. And their primary device is like a consumer device which has USB connectivity only. So they use ADB over USB only. And that was a pain for Lava for a long time, and it still is. So is there any chance that's going to be improved? So like devices that connect only over USB, they don't have any Ethernet. They might even they even might not have any serial consoles.
So I'm going to answer as if I was Neil. That's always a challenge, particularly with the devices you're talking about, because they can get into a state that you have to have some sort of manual intervention.
Yeah, but like my main concern is this ADB over USB bit. So that it has to be, at the moment, it has to be connected to some, like to dispatcher or to something else.
Yes, so in the refactoring, then the whole idea is that there'll be this, like, container would be the right word, Neil?
Sentinel's both.
Sorry?
Sentinel's both. Okay, so like we are planning to bring in like LXC containers as part of it, like something similar to what you're trying out in with the NUC kits and connecting to other devices. So we'll have in place of NUC kits, we'll be having LXC containers. That is one thing. The second thing is like talking directly with the help of ADB. Like these devices which you're talking, like do they have ADB connectivity? No.
Which device, like the host or the
Like the USB devices. I mean, devices which
but the host or the target?
the target.
Yes, no, that's all they have. They have nothing more.
Okay, so we can connect via ADB to these devices.
Yes, exactly. Only.
Okay, okay,
But ADB over USB.
okay. So in that case, like we are like experimenting on the LXC devices, where like it'll be an interface to those kind of ADB devices instead of using an NUC or a third device like KVM, which we used to do. So it'll be like in the sense of dynamic VMs. So what happens is, as soon as you fire, request for such a kind of an ADB device, so it will automatically get connected via an LXC device. So all the communication which happens will happen through this LXC device. So this LXC device will have direct access to these ADB devices, and whatever you want to do could be done via this LXC device. The advantage of doing this is like we used to have the dummy devices previously, but it was like running on the dispatcher, same dispatcher, and it is running in the same operating system which the dispatcher runs. So we had all the security issues and stuff like that. So we are like separating it from in terms of a container, so it doesn't affect anything and it cleanly gets destroyed after the test is over. So
Okay, so will it be sort of transparent?
yeah.
So if I get the multi-node test, will it be acting as a host, or it will be transparent to them?
It'll be transparent. It'll be like, we are building an ADB protocol around it. So if you issue a ADB command from a Lava test shell, it'll be like routed through the LXC device to the ADB device, the Nexus device. Or whatever.
I'm feeling lost.
Yeah, so I'm a bit confused as well. So let's say I've got a couple of ADB devices with just USB. What are they plugged into? They're plugged into
Into the dispatcher.
into the dispatcher.
Into the dispatcher.
And so we've had problems trying to pass ADB connections through to KVMs. This isn't going to. So
Container that uses the host kernel. So as
Right.
long as you get an ADB running inside the container is working, it should work. I think one thing that we have, I'm sorry. One thing that should be considered here, if it already hasn't been, is the ability to switch the LXC container use, because like right now, Lollipop uses OpenJDK 1.7 to run the CTS. It's a requirement to run some of the tooling around that. But in the future, with the Marshmallow release, that could be 1.8, and we need to be able to support both. So if we still want to run tests on Lollipop, but also Marshmallow, we need to be able to configure the environment in which the LXC environment is running in. So that's something to consider as well. Because that's the problem we have right now, whereas if we want to run with a different JRE, that's a system change, right? And we need to try to isolate that as much as possible.
no, I fully understand that. But I wasn't really getting the picture of the containers, how they worked. Okay, that makes sense for me. Yeah.
Okay. So how big is the container then?
To start with, like
okay,
the container.
so I'll give you the use case. So the use case is, for example, I need to run CTS. Full CTS is 300 megs. Do I install it in the container, or do I install it in some like other place like KVM and then run it through the container?
No, it'll be installed in the container, LXC container.
Okay.
So that's a whole point. So if you want to have different kind of Java versions, you install that on the container.
Yeah, but how big is it? How much space do you have?
The container is an application level stuff which uses the kernel features. So what happens is whatever RAM, whatever like hard disk space which is available on the dispatcher will be shared with the containers, and the container runs within a a limit so that like it doesn't like overkill. I mean, it doesn't interfere in the host operating system's run. That is, whatever the dispatcher is running on, it won't take entire resources. So it will get shared resources from the host. So how big is a host? So you
Okay,
can like
okay,
run the
got it.
container.
So now, so do I have to rewrite all my tests now? Okay.
Yeah, the answer is once we get to the refactoring, all the tests are going to have to be rewritten
Yeah, but
to take advantage.
But do we basically go back to the Lava Android test?
No, it's not like that. No.
But it looks like this.
You have direct access to ADB, where it's not wrapped in the log Android test, the Python wrapper.
Mm-hmm.
So you can write a test definition that essentially mimics what log Android test does.
Well, I don't want to go there. That's what I'm saying.
So I guess how does that change your workflow? How does that change your workflow?
So, like at the moment, I'm trying to mimic what I'm doing on my desk.
Which
So-
is exactly what you would do with CentOS.
So I have my host and my target, right? And I'm running CTS from my host to my target, which are connected with USB, full stop. And I'm doing the same with Lava. So I'm setting KVM as a host, and I'm having the target connected through this dummy.
Yeah, so the only thing in your test definition that you'd need to change most likely is the call to ADB would be the Lava Test Shell API that wraps ADB to proxy through the container. So anytime you want to make a call to ADB to use something, it needs to be using the Lava API so that it can be routed through the container. Does that make sense?
Yeah, it does.
Because then it's like you're sitting, it's like it's connected to your host machine seamlessly. That's the idea, at least.
Yeah, then we'll have issues with workload automation. It calls ADB directly.
So what would you propose to solve that?
I don't know. Well, we can add a patch to workload automation to like as a transport layer there. So that can be done, I guess.
We can expose whatever you need exposed from the ADB that you need to make. The ADB call you need to make, it can all be exposed to actually how you need to do it. It's just we need to know what of the calls you're actually using, and we'll put that into an API.
Yeah.
The point is that it's all behind it's all in the Python code running on the dispatcher, and then there's a signal interface to the test shell. But it's actually running an ADB shell anyway.
Yeah. Is this already implemented?
In review.
Sorry?
In review.
Yeah. Okay. So I guess we'll need to start testing it as soon as possible because this will be the very first use case that we're going to hit.
Does that basically answer your question?
First one.
I'll go around. Right, does anybody else have a...
Oh, thanks. So I have a couple of use cases. I'm really new to Lava, so I was just curious if these could be covered. So in leg, you know, we're getting to the point where we're ACPI and everything is starting to come together. So there's a couple of use cases. One of them is kind of what is going on with Lava right now, right? Where you can kind of define a kernel and a root file system and go. So the first question is, what's the status of that with ACPI and UE5 firmware? Has that been tested or developed yet, or is that still something coming soon?
So bootloader deployment? No.
In the new dispatcher, but I think this works currently. We have to be by platforms.
So, yeah, so, I mean, we do this. So, for example, on Juno, we can deploy firmware on that. So you can specify the firmware you want, and we can boot up with that.
Okay.
There are certain platforms we can do that with easily, even with the current Lava, but...
So let's assume the firmware is static on the board. Like we're not
Oh, yeah, we like
worried
that.
about that. The firmware is there. It's ACPI enabled. I just want to boot an ACPI enabled kernel and get to a root file, you know, to a user space.
That's no
That's no problem.
Yeah.
Okay. Good deal.
Just, I think, well, I'll throw this out there because this is something I think we need to do. UEFI is terrible for automation. It's one of the worst bootloaders to configure, to do, just I guess coming from the embedded world where we have all the control of where the load addresses are and how the command line that's passed. UEFI does take a lot of that away from us. And so we're finding it difficult to get the sort of support that we've always been used to with like U-boot and other bootloaders. And so I think what needs to happen is that when we start these UEFI platforms and integrating them, we try to get into Grub. Like, so just go to Grub and we'll configure Grub because that seems to be the standard interface, the lowest common denominator between the architectures that we have. And so I think that's kind of the area we should go, especially with the enterprise platform, the 96 board one, that we should be focusing on that and just using UEFI as the first stage bootloader to get out of it and into something else.
Okay, so that's the first use case. The second use case is, let's say we don't even want to mess with that. We just want to do kind of what people are used to doing in enterprise, where you just have some sort of ISO or disk image. Everything's embedded in there. It's just kind of stock off the shelf. We just need to boot that. And the reason I know we can do it with other things, like just doing a Pixie install, et cetera, but I really like the idea that Lava is more than just installing and provisioning. It's the whole validation infrastructure. So keeping all that and then just using like a standard boot process. Is that possible?
When you say a standard boot process, you mean booting off of a hard drive?
Booting off of a hard drive, something like we're used to with enterprise or desktop.
So yeah, with the refactoring again, you basically can specify the media on which you want that installed, and we will then boot up, do our sort of go into our testing or our installation environment, install what you need, and then reboot into that image on the disk.
Okay.
So, but that's in the new refactoring. It's not current.
Okay, so it's coming soon then.
Yeah.
So actually, that sounds a lot better than I was expecting. So I'm happy about that. So thanks, guys.
Can I talk about something that isn't working that I'd like to see if we have any great minds in here that can solve? So Pixie booting is the bane of, it's not easy to automate, right? Because it's easy if you don't want to change the image, right? Because you just point it at some binaries and then.
Yeah, let's say we didn't want to change it. So let's say, like, I'm responsible for building my own image. I'm going to put it somewhere. I just need you to go get it, rather than having to like have Lava take a stock image and then try to embed something in there and then do it.
Right. Yeah. Well, more or less. I think we can't really support Pixie booting because Lava. The idea is Lava does change the image because you're testing something, right? You want to make a change somewhere and you want to be able to get it on there easily. And I think Pixie is a great system to do that. The problem is that it requires infrastructure, right? Where you have to reload your DHCP server when you want to make a change to the file name and things like that, which is not something that you want Lava banging your DHCP server, restarting it every once in a while. So I had a thought on how we might be able to do this, and it does take a little bit of infrastructure. So you configure the DHCP server to do static IP addressing, which we do pretty much in all the devices today, and we give it a unique host name. And then we give it a file, and the next server that's configured in the lab is a dispatcher, right? So all the dispatchers have TFTP server on it, right? And essentially that's what Pixie's going to do. So it's going to go and ask the DHCP server for the Pixie information, which is then going to return going, hey, go talk to the Lava dispatcher. And the Lava dispatcher can hand it whatever Pixie configuration it wants with all the addresses relative to that. And then we could dynamically deploy Pixie. Now the problem is that works with one dispatcher. When you start saying, well, I've got multiple dispatchers, then you need to keep your DHCP configuration mapping. Say this board's connected to this dispatcher, so hand that the next server IP address or host name, and so that would work. Do you see?
It's just a moving program.
Yeah, but I mean, so does that seem like a reasonable solution to Pixie?
Yeah, definitely.
Okay, well, hey, that was easy.
Yeah, there we go. So, yeah.
Okay, so first a little introduction. We folks over here are from, with B Square, we're contracted to Google ATAP, working on Project Aura, which as everybody knows probably is a modular phone. And we're coming up in a phase now. I think test effort has been kind of neglected. And so there's a mad scramble to get everything going at once. And so I guess probably 8 weeks ago or so, I started on the sort of the Lava trek, right? If I can, I'm not going to turn this into a complaint session, but I wanted to share what I found that was difficult about getting ramped up. Notwithstanding, and we've talked about this, the sort of maybe it was miscommunication on the IRC channel and things like that, but But so what our goal is to support actually multiple versions of hardware going forward, and each of them have a sort of unique requirements. One of them is we have five ASICs that require firmware blobs, and plus a off-the-shelf microcontroller that also requires a firmware blob. And the solution that we came up with initially, well, the final solution was to be able to load those firmware blobs over what we call Unipro. I don't know how many people are familiar with that, but it's high-speed network that from the host to the from the target system to the Project R specific subsystem. So that wasn't available, and it probably isn't going to be available for several more hardware revisions down the road. So the solution we devised was to be able to push firmware blobs from the Lava server to the target, to these ASICs. And we used hardware programmers, actually, flash programmers attached to SPI-ROM headers on the board. So 1, 2, 3, 4, 5 of those devices, plus a J-Link, a Segger J-Link, to push the firmware blob to the off-the-shelf STM32 controller. So right away we had these weird requirements that we needed to extend Lava to do this, and it just wasn't there. So we had to fork starting at August and add this code, we being me, for now. And the process of just getting something working, we were working at the time with the Jetson TK1 board and of course our custom hardware that's attached through USB, which has all the ASICs on it and everything. And what I found was, going in at the front here with no prior knowledge of any of this stuff, and actually very little experience at configuration, test management, things like that, was the documentation seemed fairly opaque. Meaning there was nothing that said, start here, do this, 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 and this, and at the end it'll basically work. That was the biggest obstacle to getting going right away.
Okay, so I know we've talked on IRC quite a lot. I can't do anything but agree that for somebody coming with no background, no knowledge, that it's a little difficult to dig out the stuff you just need to get started. Lava is an open source project. If you think the documentation's wrong,
write it,
fix it, and push the changes up. That's probably a bit flippant, but it's a valid comment. I think it is a valid comment. You should have seen the documentation 3 years ago. It wasn't there.
Well, fair enough. What I thought was good was that there were ready-made classes to support fast boot as well as U-boot over serial. And although I ended up taking the best of both worlds and kind of combining them in yet another class to support our devices and their special needs, the firmware download and other things. Yeah, I thought that was really great. And of course, the big win is the promise of remote, no-touch operation, that you can have multiple installations around the world. That wasn't clear to me at the beginning. That actually isn't really possible. You need to have the master and workers on essentially the same machine or in the same subnet or something like that. And having them, well, for what I was doing, it seemed like having a master in one geographical location and then a worker in another seemed like that wasn't really it was a no-go.
Up until 3 months ago, our master was in Germany, and all the dispatchers, the majority of the dispatchers were in Cambridge.
But with full-time network stable connections, full-time static
yeah,
IPs,
that's
all that.
important.
So there's all this infrastructure, and I was just thinking maybe that it would work, sort of over the cloud, but really, you just kind of have to have that static IP network, WAN infrastructure in order to get that to work.
And I think that's a lot. Yeah. That's actually a good way.
And how do I do things? I'll just read down your first slide here. What's good, what's bad, what's helpful. How do I do things? Well, I didn't know any better, so I installed PyCharm on the Lava, the machine running Lava dispatch, and I was able to debug that way. No information in any of the docs about that. It wasn't too hard, but getting it to run in root and things like that, yeah, there was a lot of Googling involved, and that could be better. So what would you like in the future? the ability to select custom devices from a drop-down list. There, how's that?
So can I go back to your first point real quick? So I think we talked about this earlier today, but I think the biggest pitfall people have with Lava is they're like, "Ooh, cool, that's neat. I'll install it and I'll take my custom piece of hardware and I'm going to try to integrate it." And that, I'll tell you what, we've been doing this for years and it's still difficult to do for us. So don't get frustrated with that. If you'd sent that board to us, we would have probably grumbled and been like, none of this stuff's really meant for this purpose, and kind of shimmed it in there. So be aware of that, but at the same time, I think, let's see how to phrase this. What could we have done to make that better? Because I don't think we're ever going to be able to stop people from saying, I've got some crazy piece of hardware that I want to put into Lava, and how do we make that easier for them? And kind of what I'm trying to get from you is, what happens if we had a stub? Or you're going to have to write a new class anyways for all the crazy stuff that you're going to do, because we just can't predict the technology. So if we just provided you a simple interface, which is like, here's the stuff that was in the job file, here's all the URLs, you figure out how to wire this up, would that have been better than taking the source code and just like cutting it up and putting another class in there? Basically, I'm looking for, could we make the dispatcher more modular so that you could write a single class with a well-defined API that would implement everything that you want, and then you could write all of your other Python that does, the special flashing for the firmware blobs? Would that be helpful?
Well, even without the firmware requirement, just getting a fast boot device up or a serial bootloader device up, part of the problem, at least from my perspective, was that none of the keywords in the config files seemed to be defined anywhere. There didn't seem to be here is this, and these are the values it can assume, and this is what those values do, and here is how those values interact with other aspects of the config. So the device types really, if there was just quite a bit more documentation on how to do a custom device type from scratch, and adding the other stuff, it would be great. Yeah, if there was an extensible class of some type that you could just tack on your stuff, and there you go. That would be great.
Just to empathize with you on that, the config stuff, I've been doing this stuff for 5 years, and I still have to go, oh yeah, which way around does that one work?
I appreciate it.
Yeah, and it's one of those things that's there in my mind all the time. It's like, you know what, I should just go through config.py and just actually comment every single damn line. It's like, this means this does this is what it's used for. And then we'll probably find about half of them are not used anywhere anymore.
I did run into that actually, a couple different things. Well, very good. That probably wraps it up for me.
I'm going to make a really obvious request. Please, could you file bugs about some of this? There is a Bugzilla to go with.
I'm working on a forked version of 2015-8, so if I knew
Sure.
how to do that.
Oh, absolutely. Still, even, for things like if places where the documentation doesn't help, or you think there is no documentation, that kind of thing, we've all heard what you're describing. I think, Dave and I and Tyler and Neil all have a lot of sympathy with that. Like I said, especially me, I was fighting with this for months. Again, the way that I found how to do a lot of things was pestering Neil on IRC or whatever, which of course doesn't scale because there's only one of him.
Gotcha.
So
bugs.
definitely bug reports, just if nothing else as a reminder to say, I wanted to do this, but I couldn't find the particular terminology to use, that kind of thing, is a great thing for us to pick up on. One of the biggest issues, and I see this all over the place in lots of different projects, of course, the documentation is written by the people who already understand it all. So the very best thing you can do, actually ideally, would be to come and write all the docs for us, but I appreciate that's probably asking a lot. Definitely though, at least tell us the bits that your top 3, your top 5, whatever, things that you would like to see more about. And if you can help us review the docs as well afterwards, that would be awesome.
In between getting 5 hardware revisions done by January 18th. Okay.
Yeah. So just on a related note to the config stuff, there is, for every single device within the Lava Lab in Cambridge, there is a config file in a repo. So you can actually go and download all of the device type and device specific configs for all of the device types that we have in the lab. And they're really good starting points often. It's like, oh yeah, that's what that does. That I understand.
I was able to do that for the Jetson TK1. I think Tyler shared a Git repository with
Right.
me over IRC, and I was able to get the basics, hard-coded load addresses and all that stuff.
Right.
Z image and the U image and all the tags and everything.
And the other thing is that we actually do have there is a class within the devices which sort of does what you do, and I'm thinking the B2120s, because they're JTAG.
Well, so his is a little different.
No, I know it's lower,
Yeah.
but yeah.
But I mean, that's why we built the JTAG class, because
Yes.
it's like, okay, well, it's U-boot after we JTAG it, but we need to deliver the images with JTAG, and it just didn't fit into any other deployment scheme. That's kind of what I was getting at, is if we had this like extensible like interface where it's like, here's data, so if you have to do these kind of crazy things with these boards, is that easier?
But I think the pipeline addresses,
Right, yeah, that's what I'm getting at.
in the dispatcher refactoring, you have this thing called a pipeline, and it's basically, here are the stages of things that I need to do. So hopefully that will...
I had that question too. Tyler answered it earlier, but I'll repeat it here for the benefit of everyone. So legacy support on the existing device types and so forth, how long is that going to continue for?
At least as long as we still are using the old job types being submitted in the lab. But
I said at least a year. Yeah.
So from the point where everything in the lab is using pipeline, the new code, it'll probably be another, my feeling as well, is about another 12 months after that. Sorry? Yeah. So it'll be for at least 2 years.
And do you foresee any changes to the legacy support as you fold in pipeline support in parallel?
So the pipeline code is already in the same code base. It's just if you submit a YAML definition, so that's another thing in the pipeline, we're going to switch to YAML for the job definition and the test definitions because it's a little bit easier. You can put comments. There's a whole list of reasons. So when you submitted a YAML file to the Lava server right now, the one that you have currently, it'll activate the pipeline code and run that. But if you submit a JSON job, it'll activate the legacy code. So they actually were shipping the new dispatcher every single release. It's just you're not activating it because you're not writing those jobs in.
Okay, so the YAML to control tests has nothing to do with that?
Right.
Ah, I didn't know that.
And
Good.
the other
See,
thing
helps.
is just if you want to enable it, if you want to go down that path, you have to actually say in the admin interface that it is a pipeline device. Otherwise, it just won't do anything with it.
Got it.
But the whole idea that with the pipeline, and maybe you can add on to this afterwards, but so the Lava dispatcher itself, or really Lava in general, was not really sat down and designed. It was like Linaro started, we need automation framework. It was like shell scripts, and then it became this web service. And to be honest, I'm not taking anything away from the original authors. They did a great job for what they were supposed to do. The problem is the technology's changed so much from 5 years ago. I mean, I think we saw that today. Looking at some of the older computer designs, and it just was never designed to be okay. Well, what are we actually doing with this system? And so last year we had a sprint. And that's the whole idea, was to actually sit down and design what we thought, knowing what we know now, what would be acceptable, framework for doing this. And that's what the pipelines represents. And so each action in the pipeline is self-contained. It does one single thing. So if you're trying to look at a Lava job, Lava might be doing like 50 different things, and then it moves on to the next thing and does 50 other things. The problem with that is, how do you know where in the code that happened? You have to go look at the source. You have to trace it yourself. Whereas the pipeline will give us the ability to say, this happened right here. And that each action, we can subclass it so it can retry. So if there's some things that are a little finicky with the hardware that you have to bang a couple times to get it to work, well, that's simple enough for you to do, because now you can just say, try this action 3 times in a row. And it's a little confusing. The actions with the old dispatcher and the new dispatcher are a little bit different. They differ a little bit in terminology, but that was the kind of the idea there. Neil, do you want to add on to that?
One of the other big advantages reflects directly back on what you were talking about with the remote workers. We knew about this problem from the moment we started using remote workers in many ways. We knew that there were vulnerabilities in the design we had to use. So during that sprint, we pushed hard, and we got a way of control, or delivering the control from the server to the dispatcher that is over ZMQ, so it's an existing protocol. It's not something we've had to invent. It's something that's already supported and used independently elsewhere. And it is fault tolerant, and it is hostname sort of based, so you can actually have lookups at either end, and the fault tolerance at either end, the buffering at either end, means that if something changes, you just keep on going until, oh, but now I can reconnect. Here's the buffer for the last bit of time you lost. And that happens either end. It's all happening within ZMQ itself. So that makes a huge difference, because then you haven't got these fragile Postgres and SSHFS connections that caused us to bring the master back from Germany and into the Cambridge lab. Those were the main reasons why we did that. But the structure of the pipeline, it does get very, very granular all the way down, and we will be putting a lot more effort into how this is exposed through the server interface. So although we're saying, yes, this is the pipeline dispatcher, it's the dispatcher refactoring, actually there are large changes in the server side, because we have got a lot more reliable information coming up from the dispatcher through the pipeline that we can now expose. We've got a lot more structural data we can now expose. We've got a lot more clarity in what's actually going on, and we can expose all of that as you go through it as well. So the server is now becoming more and more capable, and giving you the ways of picking out from the list of jobs, that job is similar to what I want to do on my custom device, but it works on that other device over there. At the moment, you're relying on the description of the job to do that. Because we've got this structural data from the pipeline of how the classes were put together when the job was built, we know whether that used the RAM disk or an NFS, or it used firmware, or if it used this bit of that class and that bit of that class. We can expose all that information, and now we can search for it and say, show me the jobs that ran on an ARMv7 board that used NFS. And that helps a lot of people then make those jumps to think, that's a similar job to what I want to do on that board. And it actually then makes the history of Lava become useful to new users who haven't actually yet got that understanding that Dave and the rest of us have, because the server will offer that to you, say, look, here's an example of what you're trying to do from years ago.
Let me ask the question about migrating to the pipeline in the opposite direction. If we were faced with 5 board revisions between now and I don't mean little revisions, I mean there's a silicon rev as well, across 5 different board revisions, and 3 form factor changes, 2 form factor changes, 3 altogether. We're looking at completing all that essentially by sometime before January 18th. Would you recommend for or against migrating to pipeline architecture or trying to implement it? Is it worth it?
I don't think right now would be the time to switch to the pipeline architecture. But I was going to address your sort of legacy support question, which I think was in there previously.
Yes.
The intention, we currently only use the JSON format in production.
Got it.
And so there is a lot of work still maintaining the existing code base. And until every single device in Lava production in Linaro is actually switched over to pipeline, which is going to take a long time, not just because we've got to do the work to do the device definitions, the completely new way of defining devices, but also because every single person or automated system that submits jobs is going to, as Milos is discovering, you have to rewrite every single test.
I think that'd be a no for now. No for us for now.
Yeah, so I think that we will still be maintaining the old code base for a good part of those 2 years.
Sure. Okay. Tail end of this, I'll shut up after I hand the mic over. Can you talk about how CTS works for us?
As far as how CTS is being run
A
in Lava,
gentle explanation for everybody here, yeah.
we call trade fed directly. But the way we do it in the ballot, like at Linaro, we use multi-node jobs for that. And I kind of explained multi-node to you a little bit, but essentially you can request multiple devices from Lava, and then you can bootstrap them with different images, and then you can run different tests on each of these devices. And we have a synchronization API that allows you to synchronize with the different devices under test. And so what we typically do is we boot the device under test with the Android load that we want to test. And then we have a KVM device that comes up with a special image that has all the Android bits on it that we need. And we synchronize when both platforms boot. And then we do, maybe Milos knows a little bit more about this than I do, but we set up the CTS test, which is essentially just making sure we have all the bits that we need from the CTS. And then we call trade fed directly with the serial number. Typically, in that configuration, the devices that we're running CTS on are not consumer devices, and so they have like Ethernet interfaces, and so we actually configure ADB to run over TCP/IP because it's more reliable, unfortunately, than maybe some of the USB stuff. So does that answer your question?
Yeah.
Who's next? It all goes quiet down.
I have a question about deployment, about Lava test development deployment. Is it possible to deploy Lava test environment offline? Is it possible?
Over what? Sorry, I didn't.
Yeah, say your question again.
I'm from Spectrum. My location is in Beijing. Last time I tried to deploy Lava, but I found Lava will try to access and work. But in China, many websites is blocked, so I cannot finish the deployment.
Yeah, so you were probably using the Lava deployment scripts when you tried to install. Was this some time ago?
Yes.
Yeah, so we've completely gone away from that, and it's packaged as a Debian application now.
Right.
And so if you can get the Debian packages, then you can install Lava.
Now, can I get the packages?
Apt-get install Lava.
Yes.
If you're on Debian or Ubuntu. So you have to have Jessie or later for Debian and Trusty and later for Ubuntu, and it's all upstream. So it comes from the Ubuntu repositories and Ubuntu and Debian repositories.
Oh, it's great.
Yeah, I think that was when I first joined. That was the biggest hurdle to get over, was getting Lava installed, which is good. I think this shows progress because people are now talking about the next step after they get it installed, actually trying to use it. So I think we've made it over one hurdle. We still have a few more to go, but you're absolutely right. I mean, that was one of the most painful things to do. And I know in China we couldn't fetch those packages, and some of those packages were a problem. So that's why we opted for Debian packaging instead.
Thank you. I have another question. Now I want to integrate Lava to other web application like Google's Garrett. Is it easy to integrate to other web application?
So Lava has an API that allows you to interact with it, and you have to do some custom scripting. There's no direct integration, but I used a similar system when I was doing Android platform development, where our developers would check in patches to Garrett, and then it would kick off a Jenkins job, which would take the patch, apply it to the source tree, rebuild the entire Android operating system, produce the images for Android, and then at that point, publish the images to an internal web server and submit a Lava job referencing those images. And it would go and run, and then we'd use the API at this point from the Jenkins job to submit the job, to wait for it to be done, and then pull the results back, parse them, and then do a Garrett review and stuff the 790 test cases we just ran into the Garrett review and give them a plus or minus one depending on if they passed or failed. So it's very possible, but there's a little bit of, I mean, it's not just Lava involved there, it's like 3 other pieces. It's Garrett, it's Jenkins. What's that? Yeah.
So this feature is totally support, right?
Yeah, I mean, that use case has been done. In fact, I think we even have some. We actually do. We have some of our projects. In fact, our Lava development uses a similar thing. So we use Garrett for code review for the Lava patches. And when we post a Lava patch, we have a Jenkins server that will go and actually apply the patch directly to our source tree and run our unit tests and do a PEP8 check, and we'll report back to Garrett. The step that's missing there is actually the submission to Lava, but the API is easy enough to work with that you can develop those.
Yes, our use case is like this. Our engineers submit a patch to the Garrett. Then he wants to verify the patch. So if lava is supported, now if that is very cool.
Yeah, I mean, and it's not like you're going to be able to just install lava and then Garrett will talk directly to lava. You're going to have to write some scripts to do that, but there's an API that gives you the access to the lava server. So you can do some really nice things, like you can actually check if that device is online before you submit the job, because there's no point in submitting Okay, yeah, so, you know, you can do things like check if the device is online. Because if it's not online, you might as well just tell the developer, hey, I didn't have any hardware to run the test on. So you can make some intelligent decisions with the API and really make it kind of, you know, custom fit for what you need to do.
If you guys have already done this before, are those scripts public?
Yes.
Because that would be a wonderful thing to share with folks.
For Jenkins and all that, was that my previous company, and that was proprietary. I mean, we could ask them to do it.
Well, what we actually have is, as part of the Lava release process, so we're not just doing the Gerrit integration of +1 or -1 on your review posted to Gerrit, but also we've co-opted Tyler's work into a functional test suite. So that is what is running in a KVM. That is what's querying the server that it's running on over XML RPC to work out what devices are online, what device types are available, are they pipeline, are they old dispatcher, going through a set of other Git repositories which have got basically the JSON jobs or the YAML jobs, working out, right, okay, I can submit that one, that one, that one, and that one. And we do these tests as a routine part of every release process. So, you know, Central's just gone through this kind of stuff for 2015.9. We ran this particular test at least 9 times, probably 10 or 12 times. And what happens is you put it through on staging, and suddenly you watch one job start, and then without any further interaction on the server, suddenly you've got a queue of 100 jobs.
So it's a lava job that tests lava. It's kind of a recursive thing.
Thank you. I have final questions about the manual test. You know, not Lava can deal with automation tests very, very well. But in the mobile device, there's some test cases need manual operation.
Yep.
How to deal with these test cases?
So at my previous company, we developed a piece of software to run over ADB that could be run in Lava to take a screen capture, right? And then you can inject with ADB a touch event and take another screen capture. And so we'd write test cases that needed to interact with the UI, where we'd say, we'd press a button, take a picture, press a button, take a picture, and that would be our baseline. And so we'd use OpenCV to compare the screenshot images and actually know if, like, you know, could we turn Wi-Fi on was one of our test cases by actually hitting the button. And so if the blue mark didn't slide all the way to the right and stay on, and OpenCV would come back and say, this isn't close enough to the baseline image, and then reject it.
And if we want to test how to emulate this action, just like a touch in different position, how to emulate this action.
Yeah, so Android offers this to you already. Yeah, so you basically have to give it an X and Y coordinate on the screen where you want it to touch. Based on your resolution for your device, you need to work that out. But that's how we were doing it. So it was ADB, and then it was a special ADB command. Well,
you mean just like Monkey?
So that Monkey uses the same facility to inject the touches. It just randomizes where the touches go. So you should talk to Yongquin from Linaro. He's built a really neat UI test application that uses this ADB interface to inject touch points, and he's here, I believe, right?
He is.
Yeah.
Okay.
Yeah. So you should try to hook up with him.
Another one which is called Android View Flyer.
Yeah.
You can find it on GitHub.
That's what actually he's
exactly the same.
Okay.
You know what we're missing is some of these things being written up and blogged about and whatever as examples of the really cool stuff that Lava can do. You know, with, you know, it's not going to do all of it for you, but absolutely the cool stuff you can make it do with some effort.
So I thought about this. And here would be a cool thing that I started to do at my house just for fun, is I've taken a GoPro camera, and using a 96 board, we load an operating system onto it, right? And then we check that the HDMI monitor comes up. So we take a screen capture, then we go through the login prompt, and we can do the similar kind of things with OpenCV to actually check that, hey, the desktop environment that we're shipping on these 96 boards is actually working the way we think. So, and this isn't an uncommon thing. A lot of the Android development shops that I've worked with have their own automation rigs that use OpenCV and capture images and stuff. So, yeah, I mean, I think we're just not a product company at Linaro, so it's hard to justify all of this cool automation. But yeah, I think you're absolutely right. Talking about the power that Lava brings that enables you to do.
I haven't thought about those things, and it's really cool. So I think we are just about out of time at this point. It's like 2 minutes to 4. I hope that was useful for people. I will reiterate, we'll be doing this type of session again in future, so long as people think it's useful. Please, please, please file bugs. Tell people what you're struggling with, and we can't promise immediate responses because resources are always constrained, but we'll do what we can.
You mentioned filing bugs.
Oh, there is a central Bugzilla.
Bugs.linaro.org.
It's linked from every
Yeah.
page of the server.
Okay. Thank you, everyone. I hope that was interesting.